Hello everyone, welcome to today's new chapter named vector. So what is vector? Vector is a quantity that has both magnitude and direction. So for example, we have AB. It is a vector whose magnitude is in the same length of AB and whose direction is from A to B. How do you know that? Because the arrow starts from A and ends at B. So therefore, the direction is from A to B. Similarly, if I write BA with an arrow from B to A, I can say that this is a vector of BA with the direction of B to A, but with the same length as AB or BA. It doesn't matter. But now, because of this direction, therefore, this BA is actually equal to negative of vector AB. Negative vector is a vector which is the same magnitude but of a different direction. So in this case, this is considered as a negative vector of AB. Now, two vectors are equal if they have the same magnitude and same direction, so they are equal vector. Okay? Two vectors are parallel if one vector is a scalar multiple of the other. What do we mean? For example, I have vector AB, and I say that it is parallel to vector CD. Okay? But they might not be the same length, right? So I can use scalar multiple to show that now they are the same. Meaning to say, maybe I have the AB here and I have a CD that is longer. I could also have an AB that is longer, but I could have a CD that is shorter. Either way, they are all parallel. So they are of the same direction but different length. Okay, now, if you are just too lazy to write so long, sometimes we can have a very simple notation of just a lower cap with a wiggly symbol at the bottom to represent the vector AB. If you do not like this alphabet, you can also use the X, or you can use K, or simply any alphabet that you like. And now, we also would like to know what is the vector which is from the position 0. So imagine you have a Cartesian plane, okay, that is from 0. So 0 here is the origin point, right? And if you have a point here, then you can name it as A, X, Y, similarly to how we have done coordinate. But you can also switch it to vector form, whereby the X coordinate we will write on top and the Y coordinate at the bottom. It's similar to how you write a matrix form. But another representation that vector could use to represent the x-axis is by using the I vector, and to represent the y-axis is by using the j vector. So let's say you have a point B, which is say negative 3 and 4. You know very well that this point here actually is somewhere here, because this is actually negative 3 and 4. So this and this is rather similarly represented. Now we go to unit vector. So unit vector is a vector whose magnitude is 1 unit. Okay, so how do we find the unit vector? In the first place, we need to know the magnitude. So how do you find the magnitude? Remember, you have a vector which is like this. So your magnitude is the square of the x plus the square of the y and square root the entire sum. So meaning to say, let's say you have a vector b. Again, I'm going to write it like this. So your magnitude is recognized by two long modulus sign will be equals to negative 3 square plus 4 square and square root it. So what do you have? You have 9 plus 16, am I right? And square root of 25 will give you 5 units. Okay, now we have the magnitude. So how do we find the unit vector? So the unit vector here will be when the magnitude is equals to 1 unit. So the unit vector of B, which you can use or write it as B cap, is equals to its vector divided by the magnitude. so which is equals to negative 3 over 5 and 4 over 5. Now if you feel that it is too lengthy to write it like this, you can switch it back to vector I and vector J. So pretty much this is what vector is about.